Today we are going to talk about our TEKS from our Classifying 2 and 3D Figures unit. So there are two main TEKS in this one, 3-6A, which is your readiness TEK. That asks us to classify and sort 2 and 3-dimensional figures, and then it gives you this list of 3D figures using formal geometric language. Now in this TEK, we're not limited to a specific 2D figure. We could be using any 2D figure to classify and sort. So think classify 2D figures or 3D figures. Sort these into 2D figures or 3D figures. In that TEK, we're not limiting what 2D figures we could use. However, in 3-6B, we are asked to use attributes to recognize this specific list of 2D figures or quadrilaterals: rhombuses, parallelograms, trapezoids, rectangles, and squares as examples of quadrilaterals, and another verb, draw examples of quadrilaterals that do not belong to any of these subcategories. Now, I want to talk about some specific things with vocabulary. So in your scope and sequence, you have a vocabulary page that will be a tremendous help to you during this unit. So you will need to refer to that. You will want kids to refer to that. What I don't want you to do is take class time to sit and write definitions. Kids don't make sense of things that way. They don't remember. They need to use hands-on, and they need to interact and discuss. So let's talk about what these things are. First of all, a giant issue that we always run into is helping kids understand a square is a rectangle, but a rectangle is not a square. A square is a rhombus, but a rhombus is not a square. So let's talk about how we help kids understand that. So we are going to talk about the attributes of a rectangle, and then we're going to see if a square fits those attributes. So a rectangle, we know it's a quadrilateral. We know opposite sides, and I'm going to abbreviate, are equal. We know all angles are equal. They're all right angles. They're all 90 degrees. And we know opposite sides are parallel. So let's think about a square. What of these attributes does a square also have? So if I look at a square, is it a quadrilateral? Yes. Are opposite sides equal? Yes. Are opposite sides parallel? Yes. So all of that is true. Are all angles equal? Yes. So a square is a rectangle. Now, is a rectangle a square? Let's do the same thing. A square's attributes. It is a quadrilateral. All sides are congruent. All angles are congruent, and opposite sides are parallel. Is that true of a rectangle? Is it a quadrilateral? Yes. Are all sides equal? No, only opposite sides are equal. Are all angles equal? Yes, they're all 90-degree right angles. Are opposite sides parallel? Yes, but because it doesn't fit all of the attributes of a square, all sides are not equal for a rectangle. A rectangle is not a square. We could do the exact same thing for a rhombus. So let's do that. A rhombus. It is a quadrilateral. All sides are congruent or equal. Opposite angles are equal or congruent, and opposite sides are parallel. That was terrible handwriting. How about for a square? what of this is true? It is a quadrilateral. All sides are equal. Opposite angles are equal. And opposite sides are parallel. So a square is a rhombus. Is a rhombus a square? Well, we're just going to use the information we already have right here to see what we can figure out. Is a rhombus a quadrilateral? Yes, it is. Are all sides equal? Yes. Are all angles equal? No. Opposite angles are equal. Are opposite sides parallel? Yes. But because a rhombus doesn't fit all of the attributes of a square, a rhombus is not a square. So hopefully that will help you and your students make sense of that understanding. The same thing works for rectangular prisms and cubes. A cube is a rectangular prism. It's just a special rectangular prism because all sides or all faces are equal. A rectangular prism does not have to have all faces equal. A cube does. So a cube is a rectangular prism, but a rectangular prism is not a cube. Some other things that we want to make sure we help students understand. One, we don't teach anything about a pyramid in 3rd grade. It's not one of our 3D figures that's listed in our list of 3D figures that we have to do. So when you find this in your set of 3D figures, we're not using this with students. This is not one of our figures that we have to use. However, it does help me illustrate the point that I'm about to make of why a pyramid has a point or a vertex and a cone does not. The definition of a vertex is a point where some sides meet, right? And you can see here, this has a point because we have 1, 2, 3, 4 sides meeting at one point. If I look at this cone, there are no edges. If there are no edges, there are no vertices. So we can call this an apex or we can call it a point, but we're not calling it a vertex. So please don't teach kids that a cone has one vertex. It doesn't. So for our purposes, we're going to make sure that we are teaching either apex or point. They don't have to know apex. That is a bonus. So that is not something that you need them to know. You need them to know it's not a vertex. So those are the main things for this unit. You're going to do lots of classifying and sorting. You're going to make sure that kids understand that the names of some shapes are categories, not just a name of a specific shape. A parallelogram is a big one of those for us to kind of work through, because kids think that if it's shaped like this, it's a parallelogram. But a rhombus is a parallelogram because it meets the attributes of a parallelogram. A rectangle is a parallelogram because it meets the attributes of a parallelogram. A square is a parallelogram because it meets the attributes of a parallelogram. So we need kids to know that a parallelogram is not a specific shape. It's a category of shapes, not a specific shape. A parallelogram is a category. Okay, the last thing I want to talk about is a trapezoid. A trapezoid has a distinguishing feature that we need kids to recognize. In order to be a trapezoid, it has exactly or only one set of parallel sides. All of these others that we've been talking about have two sets of parallel sides. The opposite sides are parallel. That's not true for a trapezoid. That's what makes it a different shape. That's why it can't be classified as a parallelogram. A trapezoid has one set of parallel sides. And I want them to know it's only one set. So a trapezoid, again, is not only going to look one specific way. A trapezoid can look like this. It can also be rotated and look like this. Or it can be a right trapezoid and look like this, because one set only of parallel sides exists. This is parallel to this. This is parallel to this. This is parallel to this. It is a trapezoid. It doesn't have to have a certain number of congruent sides. It doesn't have to have any congruent angles. It has to have exactly one set of parallel sides. That's the distinguishing feature. And that's what makes it a trapezoid. Again, if you have any questions, please let me know. Please, please do not spend a day writing vocabulary in kids' journals. They won't make connections. You need to get these shapes out. You need to have these kind of conversations. They need to be doing sorts. I have made a couple of sorts in your Google shared drive that you can print on cardstock and have for kids. They need to be doing lots of hands-on to make sense of this unit.